Comparator's outputs switch from high to low, depending on the different values of Vn. So here's the circuit that I set up. And effectively what we're seeing is 2.5 volts on the inverting, and then depending on the potentiometer, 0 to 5 volts on the non-inverting. And because we know that the op-amp is limited by the rail voltages it's being given, our transfer function looks more like this, where this is V out and this is V in. We know that in the absence of feedback, V out on an op-amp is going to be the gain times the difference from the non-inverting and inverting output. So we're going to have the potentiometer value minus 2.5. And because the slope is so steep, although it's not an instant step, it feels that way because the slope is so steep. Exercise 1, we're going to analyze this non-inverting op-amp circuit. And we know that by rule 1, there's no current in or out of the inputs. So yeah, just this current and this current have to match. So here's the current through R1, and then here's the current through R2. And if we just rearrange these equations, we find that we have a rule 2. So this is our final equation. V out is equal to V in times R2 over R1 plus 1. And that's our non-inverting amplifier because there's no negative sign. Okay, so I made some slight modifications to the processing code, mainly just changed the legend and then added 4 different values being read in. But besides that, it's the same. So this is a voltage follower. V in is the same as V plus, and V minus matches V in. So that's why V in, V minus, and V plus all are on top of each other constantly. We're only seeing the yellow, V plus. Due to the specs of the op-amp, V out cannot follow below approximately 1.7 volts. The 5 volts is the max we have, so we can't go above that. And the op-amp saturates at about 1.7 volts, we can't go below that. So if we want our gain to be right here, if we want this to be 10, then I'll select a 1K and then a 100 ohm resistor, so that our non-inverting pin can be set to 2.5 volts. We have a voltage divider here, and yeah, this is how we set up our circuit. So if we work out what V out we can expect, we can see that there's kind of like this reference value, and then depending on what V in we give, we'll get either this or below that. But of course, there's limitations of the op-amp, so we might not see the high rail voltages or the low rail voltage values. We can tell that it's inverting because when V in is below the reference voltage, which is in this case V plus 2.5 volts, when it's below that, then our V out is above, and when we move our input voltage above that reference voltage, our V out is hence below. The V out plateaus at 2 volts as the lower boundary, and it plateaus at approximately 4.1 or 4.2 volts for the upper boundary. And that's just because of the limitations of the rail voltages, the 0 to 5 volts, the characteristics of this specific op-amp. So here is this circuit, it's an integrator. So if we know that ideal op-amps will do everything they can to match these voltages. So this is 0 volts, so this is going to be 0 volts. And there's no current going in either. So if we use KCL, we know that this current has to be the same as this current. We know that the current through a capacitor is the capacitance times the change in voltage per time. So current in, and we know that the VC, as in this VC, is equal to negative V out. So we can substitute this for V out. And if we just rearrange this equation right here and we integrate, then this is our solution. If we use the values of right here, we find that the gain is negative 21.28. And if we integrate from 0 to t, then we can expect a DC input like this. We know that when we integrate a straight line, we're going to get a slope. And our slope is going to be like that. It's going to be negative. So here's our input at 0 volts. If I adjust that input, then we see our slope appear. And it might not look exactly linear just because of the timing of our sampling, but that's supposed to be a straight line. But that slope only appears when I go to this value of 1.5 or 1.8 or something. I don't know why it's not constantly there.